HP laptop, I would press Shift and then right click. Once I do that, a pop-up will occur, and the pop-up will give me options to copy as path. So this is what I mean. You see, copy Uganda district as path name. So if I copy this, go back to R and paste it down here in line 27, you see it has part of its contents include this. So we have users, Damariski Monge, Dropbox, Dama, IDEM. But remember, this is what I specified as my working directory. And because I already did this, there's no point in specifying these elements in when I'm reading the shapefile to R. So what you see here, this is just the shapefile folder where the specific SHP is in and the specific file that I am reading. So that's working directory. So once I have done this, I want to use the write function to read the shapefile. And the function that reads the shapefiles is stread. Stread comes from the SF package. Okay? So stread comes from the SF package. If I run this code, remember we mentioned also the use of a pipe, whereby we said a pipe connects your line of codes. And it's a nicer way of telling R, number one, first do this. After you do it, move to the next operation and link it to what you did in the first step. So at this point, I want to retain unique names. And I want to show you why I want to retain unique names by running the code before I pipe it to the next line, so that we observe. You see, this is Uganda, and these are districts in Uganda. So for the districts, there are some which are repeating. How do you identify repeating districts? You use the function duplicated, which is this one. I am in line 30, and if you run this, you are able to see the duplicated value under the Ugandan districts, and that is Arua. So that's why I have a pipe that is telling R to drop any duplicate values and retain only what is unique. And if I do that, I immediately get to 135 observations. So what we want to do is we want to see the schools and where they are located in Uganda in a specific district. So we read this Uganda shapefile. This is a school shapefile in Uganda. And before we do anything to it, I want to read it so that we can see the specific elements in it. So remember, I am running it, excluding the pipe operator. That's why I am highlighting the whole of it and then running. But suppose I wanted to retain the pipe operator and do the cleaning that I want, then there is no point in highlighting everything. What I will do is place my cursor anywhere in any line of this chunk and run that code. It is still going to execute everything that I want it to execute. So if I read the school shapefile, I can see we have 16,884 observations. So this is what we have. But then remember, during our last presentation, we noticed that there are some schools which do not have the coordinates. And the best approach that is really for this particular specific work is to drop them, because we also want to retain a few observations that we can use for the practical session for this work. Otherwise, we have this geometry which has the coordinates which are in the format of northings and eastings. And that will mean it's so easy to move from the northings and the eastings back to degrees and Celsius. I mean to decimal degrees. So whenever you find a data set without the coordinates, you should never delete, but we are doing that in this session for training purposes. Okay, now that we have read the school's shapefile, we want to pick only the columns that we are interested with. We want the district name, we want the school name, we want the longitude, and we want the latitude. We want the district name because at the end, we want to merge the school's shapefile with the Uganda shapefile using the dist name and the DNAME 2019 because they have similar observations. So we want to narrow it down to 2 districts in Uganda, and we choose Apak and Arua. So that is up to line 37. But remember, we wanted to drop everything that where the longitude or the latitude is equivalent to 0. And if we do that, let me show you something. If the longitude is 0 and we drop this row, then it means it will drop everything. Like we only need to pick a column which will help us drop the rows in entirety, like, because if the longitude is 0, the latitude is 0. So we don't have to specify that we want to drop by longitude and lat. We can only use the longitude and get the results that we so much desire. So after dropping, we wanted to conduct an analysis whereby we see the different species of schistosomiasis, but this was changed. And now what we want to see is if we can locate the various schools that we have in the map that we are about to plot. And I understand this was part of your assignment. And from the assignment, there were some questions. One, how to read the shapefile. And I am hoping I have well illustrated that. If not so, I am pausing to receive questions from your end. So you can react by raising your hand if you have a question, or you can unmute yourself and speak.
There is a question.
Yes.
On that part where there is filter LON, and that sign equal to 0. Aren't we only looking at the longitudinals?
Okay. So let me read this so that we have a look at it again. So this is schools, and we say we want to filter values, observations where the longitude is not equal to 0. So these two, where I have the exclamation and the equal sign, means not equal. Like this is the language that R uses. Not the exclamation plus an equal sign will mean not equal. So in this case, I want to filter in cases where the longitude is not equal to 0. So I chose to filter by the longitude because if I do so, definitely under the longitude where we have a 0, the latitude is also 0. So it's going to serve the purpose. We can also use the latitude, like we filter using the latitude. And what we observe is that for all the entries where the latitude is 0, the longitude is also 0. So
Thank you, Damaris. Sorry,
okay, thank you. Okay,
that's clear.
okay. Any other reaction? I'm struggling to see my, okay, let me see in the chat if there is any reaction. Okay, is everyone happy?
Someone said that they were not successful with drawing the map showing the males and the females in the Ugandan data set. I think it's a Ugandan district data set.
So, and I won't be able to troubleshoot that until I see how the data set looks like. And what we can do is maybe give a chance to that person to take us through what he or she has. Like how is gender recorded in the data set? Is it and what they're using to plot? Is it a shapefile? Is it the count of gender? Like giving us an overview of the data set that is used will help us troubleshoot.
Wambi, Michael, are you able to share your screen?
Yes, I am.
Yeah, okay, you can share and then we can see that point where you're not successful with.
Well, this is what I was trying to do, basing on how you shared with me, because I tried to follow through. So when I look at the overall population, if I'm to consider the whole population, I'm basically having these ones.
So you have to load the packages first.
By the way, Damaris, I have a question on that. How come that if I have an error script like I've typed, when I come back, I don't read, you just don't go to any step. You have to first begin from the start.
Yes, you have to load the packages. Okay, the packages are like the drivers. They are the driving wheel of R. And R 100% relies on those packages to function. So if you had loaded the packages and then at some point you closed your R, when you come back, you have to call those packages again.
So there is no shortcut for that.
There's no shortcut for that. It's like it's like using your book. If you close your book and sleep, The following morning, if you want to proceed from where you left, you have to open those, flip the pages until you get to where you were.
So from this one, I came to this. And I was able to get for the whole population. So when it came to male, I tried using this to remove only the male.
Mhm.
And I had this. Now from there, I tried to assign it this.
Mhm.
Then I think that's where, because from there, when I reached this on view, it brought that.
Okay, I see where your challenge is.
Then
So you
here,
want to, okay, you want to make a subset of males, right?
Yes.
So the code for that is that you will have to filter.
Okay.
Yes, you will have to filter. Remember when I was filtering for the longitude where the value is not equal to 0, you have to do the same in your
Okay.
end. Yeah,
Damaris, can I guide a bit?
yeah, you can.
Can we view the DIST shape data just to view it? Uh-huh. So there is a column for male and there's a column for female, like you've seen. So we are
Yeah.
going to go back. We are going to go back to the command that we used to get this map. Yes, so where there is total population, you're going to remove total population and you write male.
This.
Yes. So you're going to type the word male. We are refilling the map now with male, with the
So
male population, the total population.
what of now this part that is here where you have the ggplot, the district shapefile? This doesn't change.
No, that one doesn't change. That one was just showing us the map of Uganda with the different districts. But
Okay.
now to show the map with the different populations, we fill. So it depends
change
on
it.
which, yes. So we can type mail and run it and see what it gives us.
That was a very
And you
good
need to
observation.
change the title. Yeah. You can change the title into male population.
Okay. Thank you, Praskovia.
Yeah, that was a very good observation.
Thank you.
All right. Any other reaction? Any other challenge? Okay, I cannot see any from.
Damaris?
Yes.
Yeah, for me, I don't know if it's my version of R, but my TMAP refused to upload. The package refused to upload.
So is it, maybe you can share your screen, we see what is happening.
So I've just tried to reload it again. But when I run the library thing, it says there's no package called TMAP.
So it's install.packages into bracket tmap in quotation marks. Tmap in quotation marks. And I'm hoping you're connected to the internet.
Yeah, yes, I am.
Okay.
Maybe I can stop sharing. I'll let this.
So you after that library tmap, you can
Oh,
run.
done now?
Yeah, it's done. There's no package. Error. Okay, can you scroll up a bit? Scroll your console. Your console. Okay, so error in load namespace. Lazy loading failed for package tmap. So the installation was not successful. Let me try and see. I have not used tmap in my.
So you will have to download
So
it
let me
manually.
see how it's installed.
Download it manually.
How do I do that? I go to the internet.
You Google tmap R.
Sorry.
Oh, sorry. Let me share again. I thought I had to.
You Google tmap R. R
I
package.
Google.
Yes, tmap R package. I'm only seeing your R screen, your studio screen.
Oh, I have to change screen. Okay, this is my Google search.
Go for one for Cran package. Scroll down. Yeah, package source. Download that. Go back to R Studio. Go back to R Studio. Don't open it.
Oh. Now what do I?
Go to packages, this side where you have files, plots, whatever. Go to packages, install package. Then open where it is.
Wait a second. I changed this here.
No,
Up here on Chrome.
yes.
Then download.
It's in download. Go where compressed are. Okay, so there.
Then I install. Okay.
No, it has not yet come.
Let's find the package. Thought it was there.
No, you
I
browse.
browse.
Okay. Oh, yeah,
it
it's
has
there.
come.
No, it's done. So now come here and search for TMAP in your packages.
Yeah,
Yes. Oof.
there is this.
No, first. No, I don't think it's.
Not the one.
No, it's not the one. Go down here and we see how it installed.
That's the end of the text.
Maybe.
Says there is no package called XML.
Oof.
Loading failed. Why?
Yeah. So you need, I think, to install a lower version of TMAP. Let me see the version I have. I have version 3.3.4. Is that what you downloaded? Three point 3.4 looks like it's the one.
Yeah. Do I need a new version of R? I don't know. Okay, 02.
Yeah, that's the same R I have. I have 4.2.1. I think you have an older version
Have a
of R.
lower version.
So you can download the newer version of R and you rectify it later.
Okay, thank you. I'll do that as we work.
Okay, I think we will proceed from there.
Yeah, I have an issue with my R. I mean with the code. This code where we are supposed to remove geometry. It says a placeholder can only be used as named argument.
So maybe let me do an overview. We get to that code and then I also open it up for any challenges from the team.
Okay.
Okay, can you see my screen? Is anyone able to see my screen?
Yes.
Yes, Damaris.
Thank you for confirming. So we were at a point where we had created the new variable number tested. I understand at this moment we want to show the various schools, but in case in the future you may be interested to do a similar type of analysis like the one I'm illustrating, I think this bit is essential and very useful to you. So I will explain it regardless. So after creating a new column number tested, we also proceed to creating some other columns, that is the presence of any schistosomiasis. Then we have another column which is indicated as SM, and in this case, SM means schistosomiasis mansoni. And we have another column, SH, which means schistosomiasis hematobia. I had explained the use of pmin function in these two codes, where I highlighted that I'm using the p to restrict the generated values from exiting the any schistosomiasis values. So, and this brings us to the point where we want to drop geometry, but before that, I want to visualize what we have, and we have the focus, which is numbered any schistosomiasis tables, and take note of the change of the pipe. Now we are using the or simple and the greater than simple as a pipe in this case. And what we obtain is a data frame whereby the geometry has successfully been dropped. So I will pause and take reactions. Let me get the challenge you are encountering. Bashir, let me know the challenge that you are encountering at this stage.
Yes, I get an error of a pipe placeholder can only be used as a name argument.
I'm going to stop sharing so that you project your screen.
Yeah, it is. I think it is recurring. I don't know why. But this is the code.
Do you have data.table loaded?
Yeah, I think so. Is here. Yeah. Still the same error.
And all the other previous codes worked?
Yeah. So I don't know why this, even if, even when I tried to remove it using tidyverse, I mean, yeah, it refused. Geometry refused to go.
This is interesting. Let me just confirm that your code is correct. And sometimes it's not easy to pick an error. So I'm posting a code, just run it, even if it looks like the same, similar to what you have. Just copy it and run it. We see what's happening.
Same error.
So before set DT, type, before set DT, type data.table. Like, before the function, like still in line 145, data.table, and then double colons. Run.
Same error.
No, I don't know what's happening.
And I don't see any pipe. A pipe placeholder can only be used. I think it want, I don't know. Does it want us to use dplyr?
No, you cannot use dplyr. That's interesting. Interesting. I've never seen such an error.
Yeah,
Let me see your school's data set, how it looks like at this moment.
I spent the whole weekend trying to find out
Yeah.
why this error is there.
Cool. Geometry. Okay. I clearly have no idea why you are encountering that. Who else has a similar problem?
So, what if I use dplyr to remove geometry? Does it?
The
The
set dt function is only found in data.table. So I don't think there is a function under dplyr package that functions
So
like
what does setdt does?
set this, like it's like set data frame. It's like dropping the geometry and converting the shapefile to a data frame.
I see.
Let me see.
Can we do it manually? Is everyone's code okay apart from mine?
Okay, so alternatively, you can manually select. So you can have schools, then the assignment operator schools, pipe, now from the dplyr, select, then select everything except the geometry. Yeah, that way.
Yeah, it refused to go.
Because
What is happening?
so you dplyr, include dplyr the 2 columns before select. No, and where you have select, before select, before S, type dplyr. dp, remove the, then the double columns, then run again.
Okay, let's see if it removed, because even to remove it.
Let's see, class schools. It did not remove.
Still there. Pardon? So even if I
select
use,
into bracket negative.
Mhm.
So after negative, you have a C for concatenate. C into bracket, include another bracket. Yeah, close the bracket on the end. Try that.
Geometry is still here.
I can't really figure out why you're unable to drop it using the.
And the weird thing, I can remove any other variable except geometry.
Yeah, because geometry, the function that drops geometry is setdt, and that's why I'm worried why you
So
cannot use it.
if I remove loan,
That one you will be able to remove it.
this one, that one, oh, it has also refused. Oh, wait, no. Let's remove this. It's
And what is the R version?
it's the latest 4.2.1. I really don't know. Maybe you share your entire code and I run that.
Yeah, I will share everything after I finish.
Okay.
It's,
We can go ahead and don't waste
yeah,
people's time.
okay.
Yeah.
I'll share the code and then you try it and then post it on the chat on WhatsApp chat so that we see how far you get with it. Okay. Sorry about that challenge. And then, so we have dropped the geometry. So the next step is we want to make the basic maps. And these maps, the first map will be a point map, and the other map will be include layering a specific values of a specific column on the map. So early on, I mentioned that we had to create new columns, as in lines 44 to line 46. And then I also discussed about the use of tidyr. This is the tidyr I'm talking about. Format to another, and specifically from wide to long, or from long format to wide format. And I explained what wide data looks like and what long data looks like. So with that, I'm going
Damaris, we cannot hear you.
data set to I stopped sharing. Sorry.
Yes, you still sharing.
Sorry about that. So so that's what this code is, this chunk is doing, and I will highlight it. That's line 54 to line 58. And in so doing, I specify my new columns. I want the different species to be held under a column by the name species. And I want the values, that is the numbers, these numbers 12, 3, 9, to be held under a new column, which we refer to as present. So doing that, and remember, I have assigned this to a new object name, which is schools underscore co-end underscore a park. So if I open this, first of all, I hope you all notice that we no longer have 244 observations, but now we have 488 observations. Okay. So if I view it, you see we have for Alito is now in our case being duplicated twice. And twice means we have the first row, we have the Schistosomiasis mansoni, and the second row, we have Schistosomiasis hematobium. Each school has been repeated twice. So that's why a quick way to cross-check this is here in line 56, we've said we want to transform the two columns, SM and duplicated observation of the schools. That means 2 repeating observations for each school. And if we expect that, then a quicker way to check is taking 244 by 2, we get 488. And then after running, if the value we observe under the new data set, if the observations are not 488, and then it quickly informs us that the code that we have used has not well been structured, and we have to cross-check what is happening, or it sends us back to our data set to see if every school had an observation for Schistosomiasis mansoni or Schistosomiasis hematobium. Like, that's the very easy way to troubleshoot the functionality of your code. So after generating these 2 new columns, under the species, we observe that the levels that we have is SM and SH, and initially we mentioned that for categorical variables, you want to give them meaningful labels, so that in case you're plotting, these are labels that everyone is going to easily relate with. So for instance, if you present a map to someone with the labels SM and SH, the interpretation of SM and SH will vary across your the people consuming your work. So we want to rename, or rather we want to record the species labels to Schistosomiasis mansoni, which someone can relate with, and also to Schistosomiasis hematobium, which is easily relatable. But we are not recording in the same column, or rather we generate a new column with the new variable labels. And if I run line 54 to line 61, you observe I have this other new column, which is the parasitic underscore species, and S dot mansoni, which is Schistosomiasis mansoni. SH is now called Schistosomiasis hematobium. And then I wanted to make this example as simple as possible, and I want to narrow it down to one district. If you want to check the number of districts that you have, you can make use of the function table. Table, then into bracket is the name of your data set. The beauty of R is that it also gives you prompts, like whenever you start typing, it can read your mind and give you suggestions for what you want to do so that you don't have to write a whole text. So it makes it easy for you. For instance, in my case, after typing the data set and using the $sign is what ties the variable name and the data set. It has already given me the different type of variables that are existing in my data set. And it makes it easy for me because now what I have to do is just to click on the variable that I want to summarize or describe. So if I run this, I observe that the dist name variable in my dataset has two labels, that is a pack and a row. And that's why I choose to filter to only one dist name, which is a pack at this level. And then after doing that, I'm now at a stage where I want to combine the school and a pack data frame with the Uganda shapefile. But before I do that, I also want to explore and see the various district names under the Uganda shapefile, and I will use the same approach where I say it's table. So the table function gives you a table with the frequencies and the frequencies of the individual levels that you have in your data set. So in this case, I want to explore Uganda. After that, I will show you another package that you can use that for my case, I find it exhaustive because it gives me the frequencies and the percentages at the same time. So still R has given me the various options of the variables that exist under Uganda shapefile. In this case, I'm interested with DNAME 2019. And remember that we said DNAME 2019 has the same elements like that are found in the school's dist name variable. So if I run this, it gives me a very long list, but at least I can be able to see a pack, and notice that a pack in this case is in uppercase. But then under the school shapefile, it was in a sentence case. So whenever you want to bring two objects together, and by two objects, I mean could be a data frame and a shapefile, or a shapefile and a shapefile, or two data frames you want to join. You ensure that you are joining by columns which have same observations throughout. So this makes me rename. This makes me I'm avoiding the word rename because rename is a function used when we want to change the name of a column to something else. So I want to change the name a pack in sentence case to a pack in uppercase. So I use the function record. Record comes from the dplyr package. What I want to record is the dist name, and I want to record the label a pack in sentence case to uppercase. So now I had promised to show you another package that you can use. And this package gives you the frequencies and the percentages, because you notice that if we use table is on giving us the frequencies of the count. So in this package, don't have it, you can type install .packages and then into bracket summary. Literally, let me get the correct name before I type it. The summary tools. Okay, so you can type install .packages into bracket, but remember this is in quotation marks. So you can use this to install, and I am putting it in the chat. But now, since I have it installed, but it's irrelevant to the work that I am doing, I want to library it on the console so that I can illustrate how helpful it is as compared to the table function. So I have called it to the current session, and I want to use it to explore the dist name, another school shape, the school data frame. So once I type it, R already gives me suggestions or prompts that I can use. So what you notice is that the summary tools has various functions. It even has a data set, a sample data set, tobacco. It has another data set, exams, and many more. But in my case, I'm interested with the function freq. Freq in this case means frequency. So once I have this, I'm going to write my data frame and then use the $sign and then plug in the column and then run this. And you notice I have comprehensive results. So I have the various levels for the variable dist name. It gives me the counts of the frequency. It is in this case a pack as 61 there are 61 observations under a pack, and the percentage associated with this 61 is 25.0%. And it further gives me information on missing values. And in this case, there is 0. Yes, so mostly I like using summary tools, especially when analyzing and documenting my results. Okay, this was a bit outside the topic for today, but I hope it is helpful. I am going to pause. I saw something on the chat box. Let me see. Okay. that are different from the names that I observe in the DNAME 2019 shapefile. 2019 column. And I do that using setdiff. And once I run this, it tells me that there are 0 characters that are different. But for illustration, I am going to run line 54 to line 62 and try running line 65 again. And once I do so, R tells me that a pack in sentence case exists in the school score and data frame, but it does not exist in the Uganda shapefile. And remember, that's why we had to record it to uppercase. So the beauty of R is that you can cross-check your work, you can guide, like you're the lead to what R does. So you know what you want, and then you write it in a language that R can interpret, and then R gives you the output that you want to get. So after doing that, I want to merge now the schools data frame and the Uganda shapefile, and I am merging using the dist name and the DNAME 2019. Remember, the dist name and DNAME 2019, at this point, these variables have same observations. And if I do so, I assign the output or the end result to a different name. I get 122 observations, and I have brought the elements that were in the shapefile to the I have combined the elements that were in the shapefile with the elements that were in the school data frame. Okay. And then in line 70 to 71, I wanted to convert the lat and long variables to numeric. So how to check the class of the variables is you use the class function, you pull in the data set, and then the specific variable that you want. But I think in this case, the longitude and latitude were already in numeric, so there's no worry. And then I want to check for coendemicity, and coendemicity cannot exist if the disease of interest does not exist. Am I making sense? What I mean, coendemicity cannot exist if schistosomiasis cases, in this case, is 0, or schistosomiasis hematobium is 0. For us to say that there is coendemicity, we have to observe a value of the various species that we have. So if that is the case, and then we have a justification to drop all the zeros, because the definition of coendemicity is when a certain disease exists in long time, regardless of the interventions to eliminate it. And this disease exists together with another disease. In our case, the various species of schistosomiasis exist in a specific region. Together they coexist. And then I want to convert the end result to a shapefile because I want to move to mapping. You can only be able to map when you have a shapefile and not a data frame. So to convert a data frame to a shapefile, we use set as SF. So this is st underscore as underscore SF. And what it means is set as SF object. Okay. And then we move to making a point map. So
Excuse me.
okay.
I need a little explanation of the merge. I understand merge, but what is the why did you say X and Y? I understand we are merging Uganda with the other schools park by district name. Then why do we have XY? Why don't we use one?
So we are using by.x to specify the column, the dist name column that comes from the school and a park dataset. So in this case, X is what is relating the execution to the specific dataset, which is schools and a park. And Y is relating the execution, whereby we use dname 2019 and we specify that this dname is now coming from the other dataset or shapefile, which is Uganda. Like X and Y ordered, X comes first, Y comes later. Schools dataset comes first, Uganda comes first. So in that order, pick these columns, and this column is linked to the dataset that comes first. This column is linked to the dataset that comes second by using Y.Y.
Okay, at the end of the day, do we still have two districts?
No, at the end, we only retain dist name because what guides the end output is
I
this.
mean for the database, because if we are, I don't know why we chop it off the schools and then bring it back.
So, okay. You are asking about the geometry we dropped early on.
Yeah, now we have brought it back to the main data set and it looks like it is the same.
It is not the same because the geometry we initially had was tied to the school at the school level. But the geometry we are plugging in at this moment is tied to the Uganda extent. Those are two different geometries. The initial one was for the specific school, but the current one is for Uganda as a whole. And what we want to plot is the points that are in Uganda. That's why we need to use the Uganda geometry, not the school-specific geometry. For the school-specific geometry, we want to use the latitude and the longitude so that we can clearly show on the map where those schools are found. So what we dropped early on was the geometry that was related to the specific schools. But at this moment, what we are plugging in is the geometry that is related to Uganda.
All right.
Mm-hmm. Okay, so after doing this, after now our for modeling, our data set is ready for modeling, and I have noticed that there is a I got rid of the earlier, there was a code that I had initially, but I'm going, so in my code, that's line 81 to line 103. I want to show schools where there is co-endemicity. I have specified the color for schistosomiasis mansoni, and I have specified the color for schistosomiasis hematobium. Remember, at this point, our data set is longitudinal, that is, it has repeating observations, or rather duplicated observations. So for each school, we have 2 entries, and those 2 entries represent the 2 species. And I tell R, I want to make a point map. The dataset that I'm using is called SCORE-End APAC1. The x-axis is the longitude, and what goes to the y-axis is the latitude. I want to color by parasitic species, and I want to show the school name. I will explain this after I plot the map and we see what it does. It looks like. And then I include the theme void here gives us the appearance of the map. We have different themes in R. We have theme underscore classic, theme underscore void, theme underscore BW. I mean, you get to choose how you want your graph to appear. And I am assigning a label, a title to my graph using the title function, and I specify the name. Remember, this name is in quotation marks. I have a whole section on theme, and under theme, I want to specify the various elements. I want to specify the legend text. The family, it's Arial. You can specify Times New Roman, but then for Times New Roman, you have to install a package that can enable you to switch from one font to another. Then I have specified the size of the text. I have specified that I want my legend to be at the bottom. I have specified the text for the legend title, and I have specified also the font and family for the text title. So once I do all that, I run this code and I want to see what I generate at the end. Because I want to have a clear view of this map, I will zoom, and once I zoom, give me 1 minute so that I can plug in my charger.
Maybe did you see the file? I sent it. I forwarded the email.
Yes, I did. Thanks.
Okay. So what we have the points which are colored using different shades. We have the legend at the bottom where we have species, and then we have Schistosomiasis hematobium telling us that if the shade is red, it will imply that that this specific species exists. And if the shade is green, it will imply that Schistosomiasis mansoni exists. But from this, it is so difficult for us to say which school is this. So, because remember, we want to know the school so that we can go back to Google Earth Pro Engine and edit for the coordinates, because clearly what we can see from the plot that we have is that most of the points, most of the schools are lying outside the Ugandan extent. And for Ugandan extent, please note that we are specifically focusing on a park because we filtered to this specific district. So then how do we know the schools that are falling outside a park? So I will minimize and go back to my R. And then introduce a useful package that is going to make this map interactive so that we can be able to see, to identify the various schools. And this package is GGIRAF. So I'm going to load it. And then after loading it, I want to plug the object name of my map to the GGIRAF package functions. And in so doing, I give my output, I assign my output a different name, which is map1 and then use the function giraffe and specify the GG object, that is the ggiraf object, to be the map, the object name of the map that I had plotted earlier. And then zoom the map so that it's visible. I want to set the width and the height of the end result that I obtain. So that is line 106 to line 112. So after doing so, I move further and use the function giraffe options and then specify the sizing. So the size that I want the school labels to be in. Once I do so, I want to see the end result. For easy visualization, for clarity, I'm still going to zoom. So once I zoom, I get this. But the beauty of this is that now I can be able to read, or I can be able to easily identify the school that is associated with the various shades that are outside the park extent. And when I have this school, I have Chawente, I have Abongomola Primary School, and several others. Like this is a very useful, criteria that you can use to identify which specific school is lying outside your shapefile extent. So I will pause and get your reactions or questions if you have any.
And Maris, we are not able to see the graph very well. I don't know if there's a way we can clearly see it.
It's not visible. Can you see it now?
Maybe
Okay.
like it at the extreme end.
Okay, let me share my entire screen. So what you're seeing is this.
Yes.
Okay, I know what's happening. Let me share my entire screen.
Okay.
So let me know what you are seeing.
Yes, now we can clearly see the map.
Okay. Okay, so as Ali explained, this is the plot I have, but then it's not easy, like it's not visible because it seems like some parts are chopped off. And for us to have an easy, for us to view it clearly, we zoom it. So once I zoom is when I get to this bigger R page that enables me to see everything. And I think from your end, you can also be able to see everything. So I am able to identify the various schools that are lying outside the shapefile. I have Adele Primary School, I have Abok Primary School, and several others. So this is an interactive map. What we had initially was a map with the points colored in different shades, but we could not be able to identify or to link the points to a specific school. But after making it interactive using the ggiraf package, we can be able to identify the schools. Okay. So at this point, you are able to see the location of each of the schools, and you know what to do is that you need to edit the geometry or the coordinates for your map. But still, if you're not interested in showing co-endemicity, and what you want at the end of the day is just showing the location of each school, then we have this other chunk, which is line 120 to line 141. Here, we are not coloring by any column. And what I mean by that is, remember from what we have just seen, or from the plot that we have just made, we have line 89, whereby we are specifying that we want to color the points by parasitic species. But when you come to this other code, or chunk of code, which is line 120 to line 141, where we are only interested in seeing the location of the schools, you notice that we don't have the color function. We don't have the color function here. So because we just want to see where the schools are located. So I'm going to run this code. And what we have at the moment are just these points. If I zoom, I get a point map with the same shade, or with the points colored using a uniform color, because the objective is to see where the schools are lying, the location of the schools. But then I am not able to know the school that is associated to the various points that I am observing. And this is where the interactivity is important. So we are again going to convert our code to make it interactive. So to make our code interactive, we want to convert our object, which is the coend STH APAC2. We plug it in the giraffe functions, and specify the width, height, specify the size, specify the zoom option that we want, just as we did earlier. And after doing so, the output is what I'm going to show in a few. So this is the output that we get. We have the names being displayed for the various schools. And this is what I mean by interactivity. I hope you can all see that I place the cursor on any point. I am able to see the name of the school that is associated to the point where my cursor is. But I'm not able to see anything when the cursor is anywhere on the white space. But on the point, I can see the names. On the point, I can see the names. But anywhere on the white space without the point, I cannot be able to see anything. So I have introduced you to interactivity, and I will pause for reactions or questions from your end. Kindly post your questions on the chat or unmute and speak or react by raising your hand. Any question? Is everyone okay? Can you hear me?
Yes, Damaris, we can hear you.
Okay.
I think there is no question so far. There's no question.
So are you okay? Should I proceed or pause it here and call it a day?
What do people say? Should we pause here? Phoebe, Michael, should we continue? Calvin.
I think we could stop here and first digest this.
Yes, Proscovia, I think we can pause for today.
Okay. So I am going to share the recent script so that you can have a chance to interact with it, have a chance to plug in different or use it in visualizing different variables that you are working on recently. And then from there, you can have your questions, which I will respond in our next discussion, or you can post them on WhatsApp. So thank you for listening to me and have a good evening. Okay.
Okay, thank you, Damaris, for this wonderful session. It has really been very good. Thank you so much. And thank you for the team for showing up today and for your activeness. So today we are stopping here. We shall start from there tomorrow. Yes, have a beautiful evening.
Okay, thank you. Thank you. Bye-bye.